Okay, so we're going to process the data that you got from your Alum lab. And the first thing we're going to do is look at those reactions or lack thereof that you saw demonstrated for you by your lab instructor. They were on top of the benches. The first one we saw was aluminum with water. And aluminum with water, essentially, there were no observed changes. And so the balanced equation was simply aluminum plus water no reaction, or aluminum plus water. Okay, so that was an easy one. When we added aluminum and sodium hydroxide, this was similar to what we did in the hood for the actual experiment. Aluminum and potassium hydroxide. Both of these are strong bases, potassium hydroxide and sodium hydroxide, and so they react the same way. What we saw was bubbling. So obviously there was some gas being given off. So what was the gas? Well, the aluminum was reacting with, it's solid, with sodium hydroxide, which was aqueous, and this gave us sodium aluminate, which became a solid, and hydrogen gas. And hydrogen gas. Actually, that was aqueous for you guys. And that's your bubbling. For aluminum with hydrochloric acid, this was vigorous bubbling, wasn't it? So we were making even more hydrogen gas. Let's figure out the equation. Well, this is a displacement reaction. So we had aluminum and hydrochloric acid. And if you go ahead and do your half reactions to find your net reaction, you'll end up finding that you had aluminum chloride, which was aqueous, and hydrogen gas. Now, I am not going to balance this for you. This is not balanced. You can do that on your own, okay? You need a little more practice on balancing, having looked at the exam. So make sure you balance that before you pass it in. So here I have a data sheet with some data that I got from a student a few years back. And this was what he wrote down in lab. The mass of the beaker, this was the first beaker that he had, and that he sanded down his aluminum and cut it up into little bitty pieces and then remassed it. And what he ended up with, which you would as well if you subtracted it, is 0.3176 grams. So this was his starting mass, okay, starting mass of the reactant. Now, after he went through all the different steps and finally got his alum, dried it with a Buchner funnel, but it wasn't all the way dry, he massed it just before he left the lab. Then he put it in the desiccator and left it overnight. And when he massed it, he got 28.0042 grams. Now the beaker alone had been 23.4111 grams. Okay, so he knew the mass of his empty beaker and he knew the mass of his wet alum, even though it seemed pretty dry after putting it through the Buchner funnel. This was the desiccated alum, the totally dry alum, a couple days later that I massed, and it was 26.1760. So you can see how much of a difference here we lost in mass due to water evaporating or being pulled out of that alum. So our actual yield, when you subtract these two, came out to be 2.7649 grams. Now, in order to find out the percent yield, which was something we really cared about in this experiment, we had to find the theoretical yield. And I showed you in the pre-lab how we could calculate the theoretical yield based on the mass of the starting material. So I'm not going to go through that again right now, but I'm just going to write down the equation for you. It's the mass of the aluminum, so the aluminum I should say in grams, times 1 over the molar mass of aluminum, which is 26.98 grams, times now we want to convert from moles aluminum to moles of potassium aluminate, so 2 moles of K3Al O3 per 2 moles of aluminum. And now we wanted to convert from potassium aluminate to alum, and that's a 1-to-1 ratio. This is going to be a whole lot easier if you have started doing your Chapter 4 work, because this is all just stoichiometry. And finally, we're going to convert this to mass. Okay, so let's make sure that everything cancels that's supposed to. Our grams of aluminum cancel, our moles of aluminum cancel, our moles of aluminate cancel, our moles of alum cancel, and it leaves us in grams of alum, and that will be our theoretical yield. And when I plug this in, starting with my mass of aluminum, so 0.3176, I end up finding my theoretical yield is 5.584 grams. Now, why do I stop there? Because this is 4 sig figs, and I only started with 4 sig figs. So my theoretical yield is 5.584 grams. The last thing I want to know is the percent yield, and the percent yield is an easy calculation. Percent yield is actual yield divided by theoretical yield, that's a Y, times 100%. So here's my actual yield. Here's my theoretical yield. So I have 2.7649 grams divided by 5.584 grams times 100%. And my percent yield is 49.51%. Notice only 4 sig figs because I only had 4 here. And that is how you do your calculations for the alum lab.